Hey guys, so today I'm going to discuss about third law of thermodynamics. So far we have discussed about first law and second law, PM1, PMM2, PMM3, and now we'll discuss about third law of thermodynamics. Well, this law is not that much old. We got this law early 19th century, around 1910. Right, that means 1910 years we got this law, right? To be not in a single year we got this law. It takes time to got the law, right? So this law can be also known as NERNST, Nernst postulate, right? Or Nernst statements or theorem. People also call this as Nernst theorem, right? So let's say the same, Nernst theorem. Many of my students said this, sir, Nernst theorem. Okay, no problem, we can say like this. So the other name of third law thermodynamics, like Nernst theorem and Nernst postulate. Okay, now what is third law of thermodynamics? First understand its basic concept, then we'll go into the definition, then go into mathematical expression, then we'll go into application part, right? I will share some important points regarding this also, so that those points will be very useful for you to crack any competitive examination, even for getting good score, or even for getting good knowledge, right? So let's get started with the first a diagram. So I hope so you can see here, right? So I'm getting a crystal A and crystal B. So let me just draw a crystal right way. So this will be like this, very organized way, not jumble, very organized, right? So this will be very organized, same size almost, and this will not be any jumble, right? But I'm trying to make it about perfect, but as I can see there is some jumble and small holes I have to create. All right, so this is case 1. Whenever we'll increase the temperature of this case 1, we'll get the case 2. For the case 2 it will be like this, right? Because we are increasing temperature, so there will be jumble, right? For the case 1, what we have, let me tell you, temperature is equal to absolute temperature. What is the meaning of absolute temperature? That is, temperature is 0 Kelvin. When temperature is 0 Kelvin, in that case entropy is equal to what? 0. From third law of thermodynamics we got it. And ohm is what? Is equal to 1. What is ohm? Number of microstates. This will be helpful to derive the expression of third law of thermodynamics. It's very simple, very easy to understand. I will tell you regarding this, you will understand it. Now whenever this crystal temperature is increasing, if we will increase the temperature will be increasing, temperature will be more than 0 Kelvin, then entropy will be more than 0, and then ohm is greater than 1. Things are changing. So as I told you, absolute 0 temperature is equal to 0. How is it happening? Let me tell you. And when it will happen? Is it possible? Practically, even that I will tell you, right? So what is this definition? It states that right, entropy of a perfect crystal, I can say that, perfect crystal of a pure substance, perfect entropy of a perfect crystal of pure substance approaches 0 if its temperature approaches to 0 Kelvin. What is the meaning of this? Entropy is equal to 0 of a perfectly crystal of pure substance if temperature is equal to 0 Kelvin, and many places you have seen that absolute 0. So absolute 0 means what? 0 Kelvin. Is it practically possible? No, it is not practically possible. Even whole thermodynamics is not practically possible. It is all axiomatic, means it's only theoretical. Even postulate, what is the meaning of postulate? There is no practical evidence, but we believe to be true. This is not what Nernst postulate, right? So there is no practical evidence for this. Nobody so far prove it. We did not get so far because it is impossible to achieve 0 Kelvin temperature. No matter how much aesthetic or amazing or idealized condition we have, we cannot achieve this. Now let's move on to the mathematical expression, right? So let's talk about mathematical expression. Mathematical point of view. Mathematical expression. What is it? Let me tell you. ds is equal to s minus s naught is equal to kb, that is Boltzmann constant, natural log ohm. What is kb? The value of kb is 1.38 into 10 to the power minus 23 joule per Kelvin. Now for this case ideal condition, that is microstates, number of microstates is equal to 1. So this will become kb natural log 1 is equal to 0. Now for this case initial value of entropy will be what? 0. Therefore s is equal to 0. Therefore we can say this, that whenever we are getting condition of 0 Kelvin of a perfect crystal of pure substance, we are getting entropy is equal to 0. So what I have written in the definition, we have proved it by using mathematical expression. Alright, so now this is the mathematical expression of what? This is the mathematical expression of third law of thermodynamics. Now let's move on to the application part. As I told you, we cannot achieve absolute 0 temperature, right? We cannot achieve that. But yeah, we can talk about application now. Let's talk about that. What is the application of third law of thermodynamics? That will be very fruitful for us. Let's move on to it. So let's talk about application, right? Application of third law of thermodynamics. What is the application of third law of thermodynamics? Okay, so we can able to, let's say any object we have, we want to find out its entropy at temperature T. So therefore we'll use third law of thermodynamics. How? Let me tell you. ds is equal to Cp dt division T 0 to T. So what we can write, basically Cp natural log T, right? Now we have what? ds is equal to Cp natural log T. So by using this equation we can easily able to find out s. How? ds is equal to s minus s naught, and from third law of thermodynamics we know ds is equal to what? S naught is equal to what? 0, right? So s is equal to Cp natural log T. We can able to find out, right? Now for finite body we know ds is equal to mc natural log T2 by T1. What is m? Mass of the body, Cp specific heat T2, final temperature T1, initial temperature. This formula is important for competitive examination. I have seen question asked couple of times in different competitive examination, especially in India, because I am from India, right? So this is the formula and things. Now let's talk about two important points, first and second. If you are talking about entropy, which is really important for understanding, for us also, for examination point of view also. So what is first point? That if we are talking about entropy, it is a point function. It is a point function, right? But it is an extensive property. Obviously it is a property because extensive property, right? Because it is dependent on mass. Now if we are talking about entropy generation, it is a path function. Entropy can be negative, positive or zero, but entropy generation is always positive. So these are the key points. Remember these key points, they're really important, and it will definitely help you for the competitive examination, right? So guys, thank you very much for watching this video. Like this video, share with your friends, and if you are new to this channel, do subscribe to this channel, and we'll meet soon for 0th law of thermodynamics. Thank you very much. Goodbye.